the last thing we're going to cover in this lesson. We are going to be comparing different types of functions. So these are the things that we're going to do when we're comparing different types of functions. First thing we're going to do is we're going to write a model for each function. Model meaning equation, right? We're going to write a model for each function. Then we're going to make a table for each function. So once we decide what the model is, we're going to use our model, put some values in for x, and get our output, get our y values. And then from that table, we will make our comparisons that they're asking us to make, okay? So we're first going to decide what kind of a model is this can represent this situation. Make a table for that model. Do that with the other one, and then find out, can make the comparison we need to. Okay, so in this check it out problem number 3, or actually it's number 4 at the bottom of the page. We have 2 neighboring schools, and they actually use different models. It tells you right there they're not going to be the same for anticipated growth in enrollment. School A has 850 students and predicts an increase of 100 students per year. School B also has 850 students, but they predict an increase of 8% per year.
Okay, so our equation would be like...
So I'm thinking that the first thing we might want to decide is what are the 2 unknowns in this? What are the things that can change in this situation? What would our
The
x's
year.
and y's represent? So the years,
Y.
how many years, and then what else is?
850 is your starting point, so it's how many you have to begin with.
Okay.
And then wouldn't you okay, is it exponential or is it linear?
So we got to decide too. But let's first finish deciding what are the 2 unknowns. What are the things that can change? The number of years and the number of students, the total number of students. Okay, so what do you think controls the situation? The number of students controls the number of years that have gone by?
Years.
Yeah, the number of years that have gone by will control how many students there are, right? Okay, so our x is going to represent, let's write that down somewhere, that should work for both of these, right? So x should be the number of years, and y should represent total students. How many are there all together? These are schools. Okay, so School A, let's just deal with School A. Let's write down some information that we know about School A. We know that they start with how many?
850.
Start with 850.
And they write it 100 per year.
Okay, and they go up 100 per year. Okay. Well, if y is going to represent the total number of students, and x is going to represent the number of years. And this is, they start with 850, they go up 100 per year. Is that a constant difference? Is it?
Yeah, so it's
It
linear.
keeps increasing by 100 every year. Would that be a constant difference? Okay, so that's linear, isn't it? Okay, so what do you think we could? Yeah, that helps. So what kind of an equation do you think we could set up?
Y equals mx plus b.
Yeah, so then we could do a y equals mx plus b equation because it's linear. So y represents the total number of students. We need a slope. In other words, what does it keep changing by?
100.
100. So y equals 100 x multiplied by the number of years, because it goes up 100 every year,
I'll say 50.
plus the starting amount, 850. Yeah, there's
Oh,
our model for School A. Okay, while we're at it then, before we even do the model for School B, let's make our table for School A. So when x equals 0, in other words, it's starting time, what's the y?
850.
850. Now, we shouldn't even really need to use a calculator here because guess what we're going to keep doing?
Just add 100.
We're going to keep adding 100 every time, aren't we? Isn't that really what's going to happen? Because 100 times 1 is 100, and 100 plus 850, we're just adding 100 to 850, we get 950. Well, that's 2 times 100,
200,
200, and 200 plus 850 is
1,010.
1,000.
Or 1,050.
1,050. So do we really need to keep subbing into our model?
No.
Not really. We could just keep adding 100. So go ahead and fill out that table down through, what has it got, 12 years.
That school's gotta be huge.
This is a school that was out in western North Dakota probably about 6 years ago. And this is what's going to keep happening during the oil.
Tell me that one's going to be
Just mention that graduation class.
So maybe this is what we see on the program. That's a big part of what we're going to do, isn't it? Okay, do we all agree with the table? Did they all end at 2053? Yeah. Where yours ended? Okay. So now we're ready to go figure out what's going on in school B? School B. Let's get some information about school B. They start with how much?
850.
850, so they start with the same amount.
It increases 8%.
And they go up by 8%
So 0.08.
per year. So 0.08. But, so does this sound linear then?
No.
Would we keep adding 0.08? Is that what it means?
No, it's going to be
Something goes up
Exponential.
8%, we'd have to multiply, wouldn't we?
That'll be exponential.
And so when we have a multiplier, it's exponential, isn't it?
AB to the x.
So now we have our, what's our model look like for that?
AB to the x power.
Y equals
Power, yeah.
AB to the x power, yeah? Okay, well,
850.
what's going in for A?
850.
850. Oh, we gotta be really careful
Zero
here, since we
point-
use this one, B, what do we have to do with that 0.08?
Decimal.
Yeah, we have to make it as a decimal, but here's really the model we probably should be using.
Don't you have to add 1 in there?
Yeah, we have to have that R plus 1, or 1 plus R is the way I think they gave it all these, 1 plus R, not R plus 1. So the 1, why? Because we gotta count the population that it was at. 100% is 1 plus R and to the x power.
It'd be 108 to the x
So
power.
it'd be 1.08, because 8% as a decimal is 0.08. 0.08 added to 1 is 1.08. So our B value is actually 1.08, and then that is being raised to the x power. Now we are going to have to use our calculators.
So, what?
Okay, what?
Okay. Do you want us to round
Okay,
the whole person?
So when x, yeah, we'll do the first couple together to make sure we understand. So when x equals 0, what's y?
850.
850 at the start. When x is 0, that's the start. Okay, now we're going to put 1 in for x into our equation. So 1.08 to the first power times 850. Rounded to the nearest person.
And 918.
918.
Yep.
And I should probably just have mine up too so we can make sure
That's
that.
not.
That's not what you got? We're taking 1.08 to the first power, and then we are taking that answer times 850.
Never mind.
And it comes out to exactly 918, doesn't it? Okay? Then we're gonna take 918, that's gonna be our next value that's gonna be, instead of 850, or no, we leave it at 850, I'm sorry, we don't even worry about this 918. Now we go take 1.08 and raise it to the what power? Second power now. Multiply that by 850 again, the original amount. And we're gonna round that to the nearest whole person, so what's that one gonna be? 991. Tell me what you're doing.
Okay, so I did 1.08, first power, and then plus 850.
Not plus, times.
That's why, never mind.
Okay, and then for our next one, we take 1.08 and raise it to the third power, multiply that by 850. We're always multiplying by 850, okay? And then round to the nearest whole student, and our next one should be 1071, and then you go ahead and fill out the rest of that table.
You got 1050.
Yep, 1071 because it's 0.7, so we're gonna round up. So 0.5 or more of a person, we're gonna round up. Less than 0.5, we're gonna round down.
Okay, so let's try the next one.
Oh, this is the grand, how do I do exponents?
Whoa, what?
So then I'll have to clear it out.
That's way too many kids for my life.
Just go with
When you've done, finished filling out the table, don't just use mine, but when you're done, then you can compare it to mine and see how you get. You know that fast, don't you? And that says do our last thing, which is compare the models. Here's how we're gonna compare, we're gonna say whose population was larger at what point, and when did the other one take over?
schools being enrolled at 12 people.
Why didn't we take 12?
So let's, why don't you go ahead and put in the exceeds right here, in other words, when is it greater? So we're gonna, go ahead and put the word exceeds there, and then we'll fill in.
School B
So which one is exceeding which one?
B is over
Is
A.
exceeding.
B is greater than school A's population, so school B enrollment exceeds school A enrollment for the first what?
12 months.
How many years?
Or 12 years.
For the first, are they ahead of them for the whole 12 years?
No.
No.
Or when did they go behind?
In the 11th.
in the 11th year. So their population, their enrollment exceeds school A enrollment for the first, how many years? No, 10 years. So for the first 10 years
What exceeds me?
is more than, is greater than, is above. Okay, so school B enrollment exceeds school A enrollment for the first 10 years. I suppose we could make this possessive here, it makes more sense, it reads better too. School B's enrollment exceeds school A's enrollment for the first 10 years. After, or in other words, starting at 11 years, so after 11 years, maybe we should say, because it's kind of like saying, 11 years have gone by, that's why we can say after 11 years, or we can say at 11 years, it doesn't matter either or. After 11 years, school A's enrollment is more than school B's enrollment. So now school B has taken over. Are they ever equal?
No.
One time, yeah.
Oh yeah, when they both started.
In the beginning, yeah.
Why did we choose 12 years?
Why did we choose 12? You didn't. I chose it for you because I knew how far you'd have to take the table. Do you think you'd have taken it out that far?
Nope.
No.
Probably not. Then you would have stopped at about.
Then how are we supposed to know how much?
Okay, I'm gonna help you out when it's time to start the homework. I'll tell you that. Okay, how far to take your table.
Yeah.
Okay? Okay, anybody, any concerns about this? So we compared their enrollment. They actually started with the same amount, but then school B's enrollment took over, exceeded school A's for the first 10 years. And then starting at 11 years or after 11 years, school A's enrollment climbed faster.